Hello and welcome to another video. Today in this video I'm going to talk about how to make custom layers and train them in TensorFlow. Entire source is published online and with explanation. Please check the link below in description. The tf.distribute.Strategy API provides an abstraction for distributing your training across multiple processing units. It allows you to carry out distributed training using existing models and training code with minimal changes. This tutorial demonstrates how to use the tf.distribute.MirroredStrategy to perform in-graph replication with synchronous training on many GPUs on one machine. The strategy essentially copies all of the model's variables to each processor. Then, it uses allReduce to combine the gradients from all processors, and applies the combined value to all copies of the model. You will use the tf.keras APIs to build the model and Model.fit for training it. MirroredStrategy trains your model on multiple GPUs on a single machine. For synchronous training on many GPUs on multiple workers, use the tf.distribute.multi-worker MirroredStrategy with the Keras Model.fit or a custom training loop. Load the NIST dataset from TensorFlow datasets. This returns a dataset in the tf.data format. Setting the with_info argument to true includes the metadata for the entire dataset, which is being saved here to info. Among other things, this metadata object includes the number of train and test examples. Create a MirroredStrategy object. This will handle distribution and provide a context manager, MirroredStrategy.scope, to build your model inside. When training a model with multiple GPUs, you can use the extra computing power effectively by increasing the batch size. In general, use the largest batch size that fits the GPU memory and tune the learning rate accordingly. Define a function that normalizes the image pixel values from the 0, 255 range to the 0, 1 range. Apply this scale function to the training and test data, and then use the tf.data dataset APIs to shuffle the training data, dataset.shuffle, and batch it, dataset.batch. Notice that you are also keeping an in-memory cache of the training data to improve performance, dataset.cache. Within the context of strategy.scope, create and compile the model using the Keras API. Define the following Keras callbacks. tf.keras.callbacks.tensorboard writes a log for TensorBoard, which allows you to visualize the graphs. tf.keras.callbacks.modelCheckpoint saves the model at a certain frequency, such as after every epoch. tf.keras.callbacks.backupAndRestore provides the fault tolerance functionality by backing up the model and current epoch number. tf.keras.callbacks.learningRateScheduler schedules the learning rate to change after, for example, every epoch/batch. Now, train the model in the usual way by calling Keras Model.fit on the model and passing in the dataset created at the beginning of the tutorial. This step is the same whether you are distributing the training or not.